Hello and welcome back. In today's video, I'm going to be going over the 2025 APCSA FRQs and my responses. If you have any questions, let me know in the comment section down below. Otherwise, let's begin with question 1 part A. Now let's see what we have to do. In question 1 part A, we have to write the walk dogs method. So public int walk dogs int hour as our parameter. Now, in this method, we have to find out how many dogs our person is going to be walking, and we have to update the company's log and return the amount of dogs walked. So first, let's get the amount of dogs available to walk at this hour. So I'm going to be doing int amount of dogs is equal to. Now remember, company is a variable that is in your class as well. You have the object in your class, in the dog walker class. So here, we can get the amount of dogs available by doing company dot num available dogs, and we're going to be putting in our hour here. Next, we have to make a variable that we have to return. So int dogs walked is going to be equal to amount of dogs. And that's basically it. Well, if not for one condition. But we're setting our dogs walked equal to the amount of dogs because that's the amount of dogs that we're going to be walking. We want to walk the max amount of dogs possible. But speaking of max amount of dogs, we have to make sure that we're not walking too many dogs. In the dog walker class, we have the max dogs variable here. So if the amount of dogs that you can walk is greater than max dogs, the amount that you can physically walk, then the amount of dogs that you're walking is just going to be your max dogs. All you want to do after this is update the company's log. So let's go up here. You're going to do company.update dogs, and you're going to put in the hour. So hour and then dogs walked. And what you're going to do after that is just return dogs walked. And that's it. You've completed question 1 part A. Now let's move on to part B of question 1. So it's down here. Dog walk shift. Now this method just simulates the amount of money that you're going to earn from a normal dog walking shift. So let's get started with that. Public int dog walk shift int start hour int end hour. Now we're just going to start off with a variable to keep track of how much I'm earning, so int paid equals 0. So what we're going to be doing now is using a for loop to simulate the hours that we're going to be working from the start hour to the end hour. So for int x is equal to start hour, x is less than or equal to end hour. Remember, we want the less than or equals to because the start hours and end hours are inclusive. So x is less than or equal to end hour and x plus plus. What we're going to be doing is first checking our conditions. Remember, you earn a $3 bonus if you walk the max amount of dogs possible or if you walk between 9 or 17 for the hours inclusive. So first, let's check if you walk the max amount of dogs. If max dogs is equal to walk dogs x, so if you walk the max amount of dogs possible in your hour, your paid variable is going to be equal. Now, I'm using plus equals. That means paid is equal to paid plus whatever you're writing. So paid plus equals 5 times the max dogs because you're walking the max amount of dogs possible plus $3. Now, if you're not walking the max amount of dogs possible, you can still earn $3 if you walk between 9 and 17. So first, let's see, paid is plus equals 5 times walk dogs x, because that's the standard amount you're being paid. But let's just check if our time frame is between 9 and 17. So if x is greater than or now you can either do this 2 ways. You can either check if x is greater than 8 or if x is greater than or equal to 9, because we're dealing with integers here. So if x is greater than or equal to 9, or if x is less than or equal to 17, then what you're going to be doing is paid plus equals 3. Because you get a $3 bonus for walking between the 9th and 17th hour. And what you want to do at the end is just return how much you made. So we're going to do return paid. Let's just double check that's what they're checking for. Perform an entire dog walking shift and return the amount earned. That's what we did here. We start here, we simulate all the hours, we check if we either walk the max amount or if we walk between 9 and 17, and we return the amount we paid. We've just completed question 1, and now let's move on to question 2, which is the signed text class. And for this one, we're writing the entire class, a constructor, and 2 methods. So let's just get the basics out of the way. We know we need to write a class, sign text, and we know that we are going to be writing some constructors. So let's do public signed text, and we have two parameters. Let's find out our parameters. Two string parameters, first name and last name. Now remember, the point of your constructor is to fill in the value of some variables here. So let's do private first, private last. This represents our first and last names. So let's do string. Remember, you have to put a string here. It's not just private, it's a private string. So private string first, private string last, string first name, string last name. Now in this constructor, all we're going to be doing is first is equal to first name, and last is equal to last name. And that's our constructor. We've already gotten one part out of the way. Now on to adding our methods. What's our first method? An add signature. You have to return, oh no, that's not our first method. Our first method is getSignature method that takes no parameters and returns a formatted string signature string constructed from the first and last names according to these rules. If your first name is empty, return just the last name. If it's not empty, return the first initial dash last name. So let's do that. Public string, because remember we're returning a string, public string getSignature, and we're taking in no parameters. So let's see what we have to do. If we have an empty string, so if first.length is equal to 0, then what we want to do is just return the last name. It's that easy. Otherwise, what you're going to be doing is returning the first character, so first.char at 0, plus an empty dash, plus your last name. Oh, let's write it here, yeah, plus your last name. That is that easy. We've already dealt with two parts of the question. Now let's deal with the final part. The final part asks for the add signature method, and does it take a parameter? Yes. So let me just write that quickly. And are we returning? Yes. We're returning one string. So public string add signature, it's public string add signature, and we have a string parameter. I'm just going to do text as our parameter. Now what do we have to do? We have to check if our parameter has a signature in the right spot. If our signature is at the end, good. If it's not, you either have to add it if it's missing or move it from the start to the end. You don't have to deal with the scenario if it's in the middle or somewhere else. So let's do it. First we have to check if it's even in there. So we can do, let's see, we can do if text.contains our signature, and actually let's just write down our signature here. String sig equals getSignature. Remember, it's in our own method, so we can call it. It's in our own class, so we can call it. If text.contains sig, if it contains our signature, then that's great. So we're going to move on to our next step here. If the index of this, so if text.index of signature is equal to 0, this we don't have to worry about it being anywhere else, just the start and end. So if it's equal to 0, that means that our signature is, this example, it's at the very start. And we don't want that, because what we have to return is moving the signature to the end. So to solve this, we're going to be using substrings. So text.substring, and we're actually going to be using the length of the signature. And I'm just going to explain what I'm doing in a second. So signature.length, comma, the length of the whole text. So what's the length of our text? It's going to be text.length. Now let me explain with an example right here. The length of this whole thing is 9, FOX, and the length of our signature is 3, FOX. So when I do sig length and text.length, we're starting at the signature wherever it ended off. We're going all the way to the end of the original text. We can see it if we did a starting index of 1. So this is 0, this is 1. Let's say our thing was aux thanks, and our signature was F. Starting at 1 would bring us here, and text.length brings us all the way to the end, and we know it works because 9 minus 1 is 8, which is the length of OX thanks. Anyways, that's what we're returning. But if our text contains the signature, but it's not at 0, that must mean it's at the end, which we like. So else, what you're going to be doing is just returning the text. Because remember, if the text is already good, we just return it. I believe there's an example of it here. Yeah, we just have to return it because if it's not at the start, it's gonna be at the end. But let's say it's not even in here. Well, that's an easy fix. All you're gonna be doing is returning text plus sig. Do we have to add any spaces? No. And that's about it. That was the solution to question 2 of the APCSA FRQs. Now we're going to be looking at the third question of the APCSA 2025 free response. This involves pairing competitors in a chess tournament. And we have to write a constructor and a method of the round class. This is the competitor class, so we just need the round class. So we're going to be doing public round. And let's see what we have to fill in our parameters. Let's add the curly braces. So let's see. It looks like we're going to be initializing this array list over here, the competitor list. Let's see. Write the constructor for the round class, and it should initialize the competitor list to contain one competitor object for each name in this string array. And the order which they should appear should be the order which they appear in this array list. And the ranks and their position in the array corresponds to their rank. So let's do that. So we have one parameter being string, an array of string called names. And all we have to do is initialize this. So first let's initialize the array list. So competitor list is equal to new array list, angled brackets, and parentheses, semicolon. We're going to be using a for list to go through our arrays. So let's do for int x is equal to 0, x is less than names.length, and x++. We're going to be doing competitor list dot add, but we have to capitalize this. Competitor list dot add new competitor. We have to capitalize this. And let's see what the competitor constructor takes. The competitor constructor is a string and a rank. So new competitor, our string is stored in the names array. So we're going to be doing names x as our string. But what is our rank? Our rank, remember here that our arrays are indexed of 0. So we're starting at 0. But 0 refers to a rank of 1, an index of 1 refers to a rank of 2, and etc. So we're going to make our rank x plus 1. Is there anything else we have to do here? Let's just check. And no, that's it for the constructor part that's part A of question 3. We initialize the array list as your constructor should do, and we fill the array list with new competitor objects of your name and the rank. Now let's see what we have to do for part B. In part B, we're going to be writing the build matches method. So let me just write down how it should be. It returns an array list, so public array list match build matches. And let's see what we have to do. You're going to be using the competitors from your competitor list, and you're going to be matching them as such. If it's an even number of competitors, then the best is with the worst, second best with the second worst, and etc. But if it's odd, you ignore the best and you treat the remaining as you would for the even amount. So if I had 5 people, I cut off number 1, and I treat it as if the 4 people was my original competitor list. So let's see what we should be doing here. First, we need to make a returning array list. So array list match, and I'm going to call mine ret list for a return list, but you can call yours whatever you want. Is equal to new array list, angled brackets, and parentheses. That's our ret list. And what we're going to be doing is using a 2-pointer method here. I'm going to do int point 1 equals 0. Int point 2 is going to be equal to the length of the competitor list minus 1. Competitor list. And as you recall, we don't use dot length, we use dot size for array lists, and we subtract by 1. And that is our pointer for the indices. And what we're going to be doing here is just first, let's check if the length is odd. So if competitor list dot size is odd, so modulus 2 is not equal to 0. So if the length of our competitor list is not equal to 0, that must mean it's odd. And we want to ignore the very first person, so we increase the length of our first pointer. Now, we're going to be doing a while loop, and I'm going to explain to you why I'm using 2 pointers in just a second. But let's write out what we're going to be doing. While 0.1 is less than 0.2, we want to append to our array list here, so retlist.add, and let's see how we have to add a match. It should be up here. There we go. In order to add a match, you're going to be doing competitor 1, competitor 2. So new match. Competitor 1 is stored in our list here, so we're going to be doing competitor list.get 0.1, comma, competitor list.get 0.2, and you're going to increase the value of 0.1 by 1 and decrease the value of 0.2 by 1. Now, why am I doing this method? I'm going to explain to you with a little example. Let's say I had an array of size 6. 1, 2, 3, 4, 5, 6. And this represents the ranks, first place and last place. When I do a 2-pointer method, I'm pointing to the very first and the very last, because I want to match the best with the worst. So I'm matching 1 and 6. Then I increase the value of 0.1 and decrease the value of 0.2. So now I'm brought to 2 and 5. And then if I do that again, I'm brought to 3 and 4. But if I do that again, 0.1 is going to be equal to 4. And 0.2 is going to be equal to 3. So at that point, we've swapped which pointer is greater, which is why our while loop works here. After we've made all of our matches, all we have to do is return our return list. So we're going to be doing return, not in capitals, we're going to be doing return retlist. And that's it. You've just solved question 3 part B of the APCSA 2025 FRQs. Now we're going to be doing the final question of this problem set, question 4. This question involves reasoning about a number puzzle represented as a 2-dimensional array. We're going to be writing a constructor again and another method of the sum or same game class, which contains methods that manipulate elements of a puzzle. So first, let's just see what we have to do for the constructor. So public sum or same game, and it looks like we're taking in rows and columns as our parameters. So let's write that here. Let's see what we actually have to do. Oh, it also looks like we have a private variable, so let's keep that in mind. A. Write the constructor, and you have to initialize the variable puzzle, so that's the array up here, to be a 2-dimensional array. And you also want to fill each element with a random integer from 1 to 9, with an equal chance being assigned to each element. Okay, let's do that. And it also specifies here, I guess if you've forgotten, that the first index is for rows and the second index is for columns. So let's just say puzzle is equal to new int num rows, or not num columns, num rows, and then num cols. Now what we're going to be doing is using a for loop to go through every single element of this 2D arrays. Now for the for loop, you can use ij, xy. I'm going to be using r and c. So for int r is equal to 0, r is less than the number of rows possible, and r++. Then for int c is equal to 0, c is less than the possible number of columns, and c++. What we're going to be doing is setting the value at that index, so rc, equal to a random number from 1 to 9. But how do we do this? We're going to be using the Java math random class, so math.random. But what do we do with this? Well, recall that math.random gives you a random number from 0 to 1 exclusive. So your interval would look like this, 0, 1. Now, the reason this is important is because let's say I just simply did 9 times math.random. The values I could get are 0 all the way, so if we just multiply this, I get 0 to 9, meaning that I would never get the value 9. Let's say I typecast it to integer, I still don't get 9 because I'm going to get 8.99999 and so on. But there will be no 9. So in order to fix this, all you have to do is just do +1. Now, my list of numbers is actually from 1 to 9. And that's all you do for the constructor. You're just creating the array and initializing it with random numbers. But let's see what our method is. Part B. Write the clear pair method. So let me see how to write that. public boolean clear pair int row int call. And let's see what we have to do. Write the clear pair method, which takes a valid row index and valid column index as its parameters. The array element specified by those indices, which has a value between 1 and 9, that's what we did previously, is compared to other array elements in an attempt to pair it with another element that meets both conditions. So number 1, your row index of the second element must be greater than or equal to your current parameter row. Now that just means it has to be on the same row or the ones below it. Next, the two elements have equal values or have values that sum to 10. So let's just go through some quick examples here. We have 0, 1, that's 0, 1, 7. It matches to 7 here, so we make both of them 0. And I believe this one, if we have 0 and 2, so 0, 2, 9 plus 1 equals 10, so that works. So let's get into coding this. We're going to be doing let's first get down the element that our parameters refer to. So int element is equal to puzzle row call. And we're going to be doing a for loop through the entire array, starting at int r equals row. R is less than the total number of rows possible. And the way you get this is by doing puzzle.length. Remember, our puzzle array is an array of arrays. And if we're just looking at the array, each element represents our row. So we're doing puzzle.length and r++. We're going to set another one, int for int c is equal to 0, c is less than puzzle 0.length. Because all of our array elements should be of the same size here, because we initialized it to be that way. So we're doing c++. And now there's something interesting. You want to make sure that when you're going through for the very first time, you don't cross over the same element by accident. So what you're going to be doing is just make a flag variable is equal to false. Actually, you want to make it true for now. And what you're going to do is if flag variable and c is equal to call. And basically what this means is if we're going through our array, remember, we're starting at our first row, whatever was put in by the user. If that c we're going over is the exact same as the column, we just want our code to skip it. And then we're going to set flag equal to false. This means that if there are any other future rows, it's completely fine if c is the same value as column, because we're not on the same row. So we can just do this, and now let's get on to the condition checking. So what we're going to be doing here is first checking if the elements actually sum up to 10. So if puzzle rc plus element is equal to 10, or if they're the same, or if element is equal to puzzle rc, then what we can do is we can set them both to 0 and just return true. Puzzle rc is equal to 0, puzzle, and we can set our puzzle row column, which is where our element was. So puzzle row and column is equal to 0. There we go. Is equal to 0, and then what we're going to be doing is just returning true, because we did find two elements that either added up to 10 or they were the exact same. And as we can see here, we're making sure that the only elements that you can look at are at the exact same or later rows. So we're returning true here, and that's it. We set everything to 0, and all you have to do here is, here we go, make a return false here. And the reason we're doing it here is because if we've gone through this entire array and we haven't found a single true pair, that must mean that none exist. So we're going to be doing return false, and there you go. You've answered every single question of the 2025 APCSA FRQ, the free response questions. Again, if you have any questions, let me know in the comment section down below. Otherwise, goodbye.